Good morning, dear students. My name is Ferhan Mazher, and today is 22nd of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels of Physics, and today we have set our hearts to solve a theory paper. We call it paper 2, and today we have selected May-June 2014 2-2 paper. This paper belongs from the zone 2, or we call it the variant 2. So in this session, in this video, we are going to attempt the section A of this paper. The section B of this paper, we will attempt in another video. So let's start today's paper, and I hope that you will enjoy this video and you will learn from this video. So let's start today's paper. So the question paper is May-June 2014 to 2. Paper 2, the total time allowed for this paper is 1 hour 45 minutes, but we are going to attempt only the section A of this paper in this video. Okay, so the first question coming up on your screen. He says, figure 1.1 shows a lorry accelerating in a straight line along a horizontal road. The driving force on the lorry in the forward direction is D, and the total backward force on the lorry is B. State and explain whether D or B is the larger force. Because we know that the lorry is basically accelerating, so I know that the forward force is supposed to be larger because the body and the lorry is basically accelerating. So what we will do, you see, the driving force is larger than the backward frictional forces. So let me show you my answer, and the answer is here. Here we come. State and explain whether D or B is the larger force. The driving force D is greater than the force B. Lorry is accelerating due to the resultant force in the forward direction. Okay, so the forward force is the driving force, backward force is the frictional force, and the lorry is accelerating, so it means that the forward force is more than the backward force. The next question in the second part is that suggest one possible cause of the backward force B. The backward force B is due to the air resistance experienced by the lorry. So my answer is air resistance in the backward direction. So question number 1, A part, it's the second portion. We are also done with this. This was 1 mark question. So let's move to the next B part. He says, the weight of the lorry is 300,000 Newton. The gravitational field strength G is 10 Newton per kg. Calculate the mass of the lorry. So we know the weight, we know the G value, we can calculate the mass. The W is equals to mg. So mass will be equals to W divided by G. Okay. So the weight will be W equals to mg. So we know the value of the weight 300,000. We know the G value, that is 10 Newton per kg. We want to find out the value of the M. So I will make M the subject of the formula. So that will be 300,000 divided by 10. So your answer will be 30,000 kg. So the mass of the lorry is 30,000 kg. Then he says find the resultant force on the lorry. Sorry, the resultant force on the lorry is 15,000 Newton. Calculate the acceleration of the lorry. You know, according to the Newton's second law of motion, we can find out the resultant force. F equals to ma is the mathematical formula, and we know the resultant force, that's 15,000. We know the mass, that's 30,000, and we want to find out the acceleration. So acceleration will be the 15,000 divided by 30,000, that will be 1/2, that is 0.5 meter per second square. Hopefully you understand. And okay, then later the lorry turns a corner at constant speed. Explain why the lorry accelerates even though the speed is constant. Okay, the magnitude of the velocity is constant. The lorry is turning on a corner, and whenever you turn a corner, you move in a circular track. And when you move in circular track, your direction has to be changed every moment. So because the direction of the velocity is changing, that's why we say that the velocity is changing, and when the velocity changes, we say there is acceleration. So there is acceleration because the direction of the velocity is basically changing. So the magnitude of the velocity is constant, but the direction of the velocity is changing. Due to this, lorry has acceleration. I wrote is acceleration. Lorry has acceleration. Okay, so we are done with the question number 1. So let me show you the marking scheme. So my dear students, the marking scheme of the question number 1 of the May June 2014 2-2 paper is showing up on your screen. You can pause the video and you can take your time and read this marking scheme carefully. It is very, very important habit to always check the answers which I gave, which you gave, which your teacher gave, or any other book gave you the answer. You're supposed to check the answer, confirm it from the marking scheme. Hope you understand. Okay, so we will move to the next question. The next question is question number 2. He says, figure 2.1 shows parts of a hydraulic jack used to lift the front of a car. So this is that hydraulic jack which is used to lift up this front of the car. So here is this handle, and here is the pivot, and here you apply the force, and this piston will go inside. This small piston will go into this small cylinder. Here we have the oil. So that oil will be pushed, and that oil will push this big large piston outward and towards the left, and then this large piston will move upward. This car will be lifted up. So this is the basically the jack, hydraulic jack. Okay, they say he says the operation pulls the handle. The operator pulls the handle and causes a force of 50 Newton to act on the small piston. The force exerted by the oil on the large piston increases by F. The large piston moves and rotates the arm about the pivot. This raises the front of the car. The cross-sectional area of the small piston is 1.5 centimeters square. The cross-sectional area of the large piston is 5 centimeters square. The pressure in the oil caused by the force on the small piston. We know the force applied on the small piston is 50 Newton. We know the cross-sectional area of the small piston is 1.5 centimeters square. So very easily we can find the pressure of the oil in the small piston. Pressure is equals to force divided by area. Okay. So pressure is equals to force divided by area. That will be 50 Newton divided by 1.5 centimeters square. The answer will be 33.3 Newton per centimeter square. Then their question is find the value of the F. F is the force which is produced in the large piston. On the large piston, the force exerted by the oil on the large piston. So that force we can calculate, according to the Pascal's principle. The pressure in the oil on one side is equals to the pressure on the other side. The pressure which you created in the oil at one point, same pressure will be transmitted to the other point in the oil. So the pressure experienced by the piston, larger piston, will be equal to the pressure in the smaller piston. So the pressure in the larger piston will be the F divided by the area 2, and that will be equal to the pressure 1, that is 33.3. Or you can take it as 33. So F divided by 5, because A2 is 5 centimeters square, the area of the larger piston. So you will have F will be 5 multiplied 33.3, and you get 166.5 Newton. This is approximately 167 Newton. So the force F in the larger piston will be 167 Newton. Hopefully you understand. Okay, so we are done with this question. Then he says, explain why the large piston moves through a shorter distance than the small piston. You see, when the small piston moves, it actually displaces oil from the small cylinder. That displaced oil, or that volume of oil which is displaced by the small piston in the small cylinder, moves and it goes into the large cylinder with the larger piston. So when that displaced volume of the oil goes into a larger piston, where there the cross-sectional area of that piston is larger, but the volume of the oil which came here into the larger piston is the same as it was displaced from the smaller piston. And in the larger piston, the cross-sectional area is larger. So now in the larger piston, because the cross-sectional area is larger, so the same volume of the oil will have a smaller height or a smaller length because the volume is same. So because the volume is cross-sectional area multiply the length of the oil, or the height of the oil. So and because the cross-sectional area here is larger in the larger piston, and so the length will be smaller of the oil of the same volume which was displaced from the smaller piston. So the larger piston will move a smaller distance. You can understand it by one example. For example, if you take a glass who has a smaller diameter, so fill the glass and note down what is the height of the water in that glass. Then pour that water into a big jug. So that big jug will have a large cross-sectional area. So when you put the same volume of the water into the big jug, whose cross-sectional area is larger, because the volume of water will be the same, whether it is in a glass or it is in a jug. So because the jug has a larger cross-sectional area, you will notice that when you pour the water there, the height of that water in that jug will be smaller because the volume in both the places is same, but because the jug has a larger cross-sectional area, so the height of the water there will be smaller. That's why in the larger piston moves a smaller distance. Let me show you my written answer. I hope you understand the description which I gave you. Oil displaced from the small cylinder comes into the larger cylinder. In large cylinder, cross-sectional area is large, so the large piston moves a small distance. Because the volume of the oil displaced from the small cylinder, when it comes to the large cylinder, the volume of oil is the same. But because the larger cylinder has a larger cross-sectional area, so there the length of the oil which was displaced from the small piston came into the large piston, the length of that oil will become smaller to have the same volume. So the larger piston is moving due to that oil, so the larger piston will move a smaller distance. Then let me show you the next part. He says the efficiency of the jack is 75%. Explain what is meant by efficiency. Efficiency means it's a ratio of the useful output energy to the total input energy. So let me show you my answer. Yeah, here we go. Ratio of the useful output energy to the total input energy is called efficiency. Okay, so we are done with this question, I think. Okay, so next one is the question number 3. So before we go to the question number 3, let's have a look at the marking scheme of the question number 2. So our answers are perfect. The marking scheme is showing up on your screen. What you can do, you can pause the video and you can take your time, read the answer, compare the answers which I gave to you, or you have written on your own, compare those answers with this marking scheme. It's a very, very important thing. So we are going to the next question, the question number 3. He says, most substances expand when they are heated. State one example where the expansion is useful. You see, we have bimetallic strips. The bimetallic strips are two different metals which are welded together. So when they are heated, or normally they are straight, in normal temperature they are straight. But when you heat them or when you cool them, they bend due to the difference of expansion in both the metals. So they bend either upward or downward during the cooling or during the heating. So that thing is used, that expansion of those metals is used to make thermostats. So he says, state one example where expansion causes a problem. You see, when you have seen those railway tracks, the railway tracks are made of iron, so the expansion in the railway tracks is a problem, because if you have not given a room for the expansion in the railway tracks, the railway tracks will become what you say, they will bend. Okay, let me find the word. He says any sensible example. Okay, so we can give a sensible example. So here we go. Expansion in the bimetallic strip to make thermostat. And state one example where expansion causes a problem, expansion of the railway tracks. So, okay. So then he says, B part, question number 3, its B part is coming up on your screen. He says, explain using ideas about molecules why solids expand when heated. You see, when you will heat the solid, its molecule will absorb the thermal energy and they will start vibrating vigorously. And the amplitude of their vibration will increase. So when their amplitude of vibration will increase, they will collide with their neighboring molecules. And they will make them vibrate vigorously, and they will make their neighboring molecules vibrate vigorously. In this way, the energy is transferred from one molecule to the neighboring molecule, and from the neighboring molecule to its next neighboring molecule. So this is, you see, when all the molecules will start vibrating vigorously and their amplitude of vibration will increase. So what will happen? The molecules will move away from each other. The distance between the molecules will increase, and the solid will expand. So let me show you my written answer. When temperature of a solid rises, its molecules start vibrating vigorously. The amplitude of their vibration increases. So the molecules move away from each other. So the molecules will move away from each other. The distance between the molecules will increase, and you can say the solid will expand. So this is how you do it. And the next question. The next part, that was question number 3B part, and it was 2 marks question. He says, when equal volumes are heated through the same temperature rise, the expansions of solids, liquids, and gases are different. Complete each of the 2 sentences using one of these expressions. Much larger, slightly larger, much smaller, slightly smaller. The expansion of a solid is dash than the expansion of the liquid. The expansion of the solids is less than the expansion of the liquid. So we will use this word, slightly smaller. The expansion of a gas is dash than the expansion of a liquid. And the expansion in the gas is quite large, is much larger. You can say it's much larger. Better word will be much larger. So remember, expansion is largest in the gases, then in the liquids, and then in the solids. So solids have the smallest expansion. So let me show you my written answer, and then we will check. Okay, the expansion of the solid is slightly smaller than the expansion of a liquid. The expansion of a gas is much larger than the expansion of a liquid. So that is our answer. So let's have a look at the marking scheme. Okay. So the marking scheme of the question number 3 is showing up on your screen. You can pause the video and you can check my answers, your own answers, and compare them. Okay. Our answers are perfect, I think. Okay, so we are going to the next question. That will be the question number 4. Okay. So the question number 4 is showing up on your screen. He says, figure 4.1 shows part of a long rope used by a student to show a transverse wave. Figure 4.1. Mark the direction of the movement of the student's hand. You see, to produce these waves in a rope, you have to move your hand up and down, up and down, up and down. So I will put an arrow here in upward direction and an arrow downward direction. The second part is, he says, mark and label the wavelength of the wave. The wavelength of the wave is the distance between the 2 points which are in the same phase. For example, this is trough, this is also trough. So the distance between, horizontal distance between them will be equals to 1 wavelength. Then he says, mark and label the amplitude of the wave. From this is the, I will draw a line here that shows the mean position of the wave. So from the mean position, how down you went, that is amplitude, or you can say from the mean position, how high you went. So that is the amplitude. So let me show you. So here you can see I have shown with 2 arrows, I have shown the direction of the movement of the hand. I have shown what is the wavelength, and I have also shown what is the amplitude. So hopefully you understand this. Okay, so let's move to the next part, and the next part is coming up on your screen. He says, describe how the frequency of the wave is found using a stopwatch. You see, if a wave is passing from a point, what you will do, you will take a stopwatch. And for example, you note down how many waves pass from that point, how many complete waves pass from that point in, let's say, the 2 minutes. For example, you say 2 minutes. And count how many waves have passed from that point in 2 minutes. Then divide the number of waves with the 120 second if you have taken 2 minutes. So then it will be 120 second. For example, if you count the number of waves for 3 minutes, then divide the number of waves with 180. So that will give you the frequency of the wave. Okay. Count the number of waves passing from a point in 2 minutes. To calculate frequency, divide number of waves by 120 seconds. So that will give you the frequency. Okay, so let's move to the next part. He says, using the same rope, the student produces a wave of longer wavelength than that shown in the figure 4.1. State how the student does this. If you want to produce the waves who has the longer wavelength, you have to move your hand up and down slowly. The hand with which they were producing the waves in the rope, that hand should move slowly. He will move his hand up and down slowly. Okay. So the question number 5, we are done with the question number 4. So let's have a look at the marking scheme. The marking scheme of the question number 4 is showing up on your screen. You can do a good thing. You can pause the video and you can take your time, read this marking scheme carefully, compare the answers which I have written, compare those answers with this marking scheme. Okay, so now we are going to the next question, and the next question coming up on your screen is question number 5. Visible light, radio waves, X-rays, gamma rays, and microwaves are some of the components of the electromagnetic spectrum. State 2 other components of the electromagnetic spectrum. You know, when we have studied that chapter, I have told you that to remember the names of the components of the electromagnetic spectrum, Remember, the Ronald McDonald is very ugly except Gary. Ronald McDonald is very ugly except Gary. The component names which they gave, I have put a tick on them. And the two which are left are the infrared and the ultraviolet. So write infrared and the ultraviolet. But also remember that to write these names in the order, uh, we use the we use this word. Ronald McDonald is very ugly except Gary. So radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Okay. Then that is the question number 5. Let me reduce the size. I think because the size is okay. That's the B part. We are done with the A part. Okay. Question number 5 is B part. He says white light is a mixture of different colors. And the figure 5.1 shows a ray of white light entering a glass prism. The white light separates into a number of colors. Only the blue light and the red light are shown. Explain why the blue light and the red light separate as shown. Using the term refractive index in your answer. You see, for the blue light and for the red light, the refractive index for both the lights is different. So because the refractive index of the blue light will be larger than the refractive index of the red light in that glass prism, so the blue light will slow down more and it will bend more. So that's why they have separated. Okay, so let me show you my answer. It says red light and blue light have different refractive index of glass. So when these lights enter glass, blue slows down more than the red, hence it bends more than the red. Okay. Okay. So we are done with the question number 5. So let's have a look at the marking scheme. So the marking scheme of the question number 5 is showing up on your screen, and you can see that marking scheme. So read it carefully, check my answer, compare it with this marking scheme. So my dear students, we are going to attempt now the question number 6 of May-June 2014 2 paper. It's A part we are going to attempt, and this question is very important because it has confused many students. A beam of parallel light strikes a converging lens of the focal length 2.8 centimeter. The width of the beam before it reaches the lens is 1 centimeter. The width changes on the other side of the lens. State a different distance from the lens where the width of the beam is less than 1 centimeter and is more than 1 centimeter. It's a very tricky question, so let me show you how I have solved it and try to learn this. Okay, so here you can see I have drawn a diagram. Here is the principal axis. I have marked after every 1 centimeter, I marks the point here. And I have placed a lens here, and the F is 2.8 centimeter away on the right side and on the left side, both sides. So at the distance of 2.8 centimeter, put a dot here. So the F will be Here principal focus and principal focus will be here. Then they say a beam of light rays coming and that beam is 1 centimeter wide. So here I have, with the help of the scale, I have drawn this black color and with this red lines is the beam of light. And this beam of light is 1 centimeter wide. So when these rays will pass through the lens, converging lens, so they will focus on F. And after that, they will like go like this. Okay. So you can see the beam of this light, which was 1 centimeter wide, has after passing through the lens has decreased, and then it starts increasing. And so you see, we are looking for the point where the width of the beam is more than 1 centimeter. At this point, the width of the beam is 1 centimeter, and this is 5.6 something. Okay. So where is the less than 1 centimeter? If, for example, at 4 centimeter from the lens, the beam is less than 1 centimeter wide. So I have written answer here 4 centimeter from the after passing through the lens. Okay. Then more than 1 centimeter. So after this, the width of the beam is more than 1 centimeter. So very easily you can say at the 6 centimeter after passing through the lens, the width of the beam will become more than 1 centimeter. So hopefully you understand this, and this is a very tricky question. So I have tried to explain to you that part. Okay, question number next one is, he says, that's the B part of the question number 6. An object is placed 3 centimeter from a converging lens of the focal length 2.8. Figure 6.1 is an incomplete scale, full scale ray diagram for this arrangement. Okay. So what they want us to do, on the figure 6.1, draw the path of the two rays after they pass through the lens. Okay. So first of all, I will mark at the distance from the lens at the distance of 2.8 the principal focus, and then I will draw the lines. So it's a 2-mark question. So let me show you. So this ray here, after passing through the lens, it will pass through the principal focus on this side, and it will go like this. This ray, which started from the head of the object, will pass through the middle of the lens, and it will go undeviated. And you see that these rays are coming close to each other, but up till 11 centimeter from the lens, they have not intersected each other. Okay, so let me check first of all. We're done. Explain how your ray diagram shows that image is more than 11 centimeter from the lens. That is the question. You see, how does your image shows this? Okay, so let me show you the image. You see, up till point 11 centimeter, these two rays, they are coming close to each other, but up till 11 centimeter, they have not yet intersected each other. So the image will be more than 11 centimeter from the lens. So that was the question number 6. Then he says, underline 3 of the following words which describe the image. the image will be inverted, the image will be magnified, image will be real. Okay, so my dear students, we are done with this part. Here in this part, I just forgot. So this question number 6, there was 2 parts. Basically, question number 6A part, we are done with this. The width of the beam less than 1 centimeter is here. So you can name any 4 or 5. And the width of the beam more than 1 centimeter is here. So you can say 6 centimeters, 7 centimeter, 8 centimeter. You can name any location. Okay, so we are done with this one also. And they ask us a very important question here. He says that explain why, explain how your diagram shows that the image is more than 11 centimeter from the lens. The reason is up till 11 centimeter, the lines are coming close to each other, but still they have not intersected. So it means that the image formed will be more than 11 centimeter from the lens. After passing through the lens, they are converging, but they have not intersected each other up till 11 centimeter. They will intersect each other, but after 11 centimeter. So then there was the question that underline 3 of the following words which describe the image: inverted, magnified, and real. Hopefully you understand. So my dear students, the marking scheme of the question number 6 is showing up on your screen. You can pause this video and you can take your time and check the answers which I give, the answers which you wrote, confirm them with the marking scheme. So we are going to the next question. So figure 7.1 shows a compass needle near a bar magnet. Magnetic poles are shown on the compass needle and on the magnet. A finger stops the compass needle from turning. So the magnet causes a force on the S pole of the compass needle. On the figure 6.1. On the figure 7.1. Draw an arrow from the south pole of the compass needle to show the direction of this force. You see, because magnetic lines are going from north to south, so the north of this compass needle will go in this direction, and this S pole will go in this direction. So let me show you. So the force experienced by the south pole of that compass needle will be towards the right. I have shown it with an arrow of red color. So hopefully you understand. Magnetic compass will follow the magnetic lines. So the north of the magnetic compass will follow the magnetic lines. Magnetic field lines, I mean. He says, explain why the compass needle turns when the finger is moved. When the finger is removed. If you will remove that finger, if you will remove this finger, the force on the S is towards the right and the force on the north is towards the left. Here is the pivot. So these two forces will produce a turning effect in the anti-clockwise manner, and the needle will rotate. Okay. So because the forces are acting on these needles due to the magnet, and the direction of the forces is such that it will rotate anti-clockwise. North of the compass experiences let me increase the size. North of the compass experiences a force towards left, and the south of the compass experiences a force towards right. So these forces produce an anti-clockwise moment about the pivot. A small compass is used to plot the magnetic field lines on of the magnet. A small compass is used to plot the magnetic field lines of the magnet. Describe how the compass is used to plot the magnetic field lines on a piece of paper. You see, the procedure is very simple. You take a white paper, and on that white paper, you place a bar magnet. You mark the boundary of the bar magnet, and near the north pole of the bar magnet, you place a magnetic compass. So wherever the pointer and the pointer will indicate, put a dot on the paper where the pointer of that compass shows. So put a dot on the paper, and where the tail of that compass needle will be, put a dot there. Then remove that magnetic compass and put it in a new location in such a way that the tail of the magnetic compass will be joining with the point which you already have put on the dot, and put then dot in front of the where the arrow of the compass needle will be pointing. So continue doing this process until you reach the south pole. So once you have put the dots on the paper, then take a pencil and join the dots with each other with a curve, and that will be the field line pattern around the magnetic field. You can then repeat this process by plotting the magnetic compass on different locations near the north pole. So let me show you my written answer. I have written this answer, so you will. Okay, so here we go. So put a magnet on paper and mark its outline or boundaries. Place a magnet compass near the north pole of the magnet. Mark the tail and head of the pointer on paper. Place magnetic compass in a new position in such a way that its pointers coincides with the mark represented head of the pointer in the previous location. Continue this process until South Pole is reached. Join the dots to represent a magnetic field line. So once you have put these dots, just simply join those dots. A good question this is. Let me show you the marking scheme. I think the paper is over. Question is over basically. So the marking scheme of the question number the question number 7 is showing up your screen. Let me show you the question number 6 is also. You can pause the video, you can check the question number 6, and the question number 7 is also the answers of the question number 7 are showing up of the marking scheme. And you can pause the video and you can take your time and read this marking scheme, compare the answers which I gave you with this marking scheme. Hopefully you understand. Okay, so we are going to the next question. The next question is question number 8, and an atom consists of electrons surrounding a nucleus made up of protons and neutrons. State which of these particles have an equal and opposite charge. You see, the electrons and the protons, they have equal but opposite charge. Electrons has negative charge and the protons have positive charge. Then the question is, have almost equal mass. The protons and the neutrons, they have the same or kind of equal mass. So electrons are negative and protons are positive. Protons and neutrons have same mass. Okay, that is the answer which I gave. Okay. The nuclide notation for the carbon 14 is C614. Carbon 14 decays by beta emission to a stable isotope of the nitrogen, while numbers in the empty boxes below so write numbers in the empty boxes below to show the nuclide notation for this isotope of the nitrogen. So whenever a beta particle is given out, remember the number of the protons increases by 1, but the number of the nucleons remain constant. So let me show you my answer. You see, because the beta particle is given out and the beta particle's atom number is -1 and its mass number is 0. So the daughter nucleus which is formed, it will have 7 protons and 14 neutrons. The half-life of carbon 14 is 5,700 years. A sample of wood from a living tree contains 2.4 x per 12 atoms of carbon 14. A similar sample of the same size is taken from an old piece of wood. It contains 6 x per 11 atoms of carbon 14. So calculate the age of the old piece of wood. Okay. So at the start, the number of the sample, the atoms are 2.4 x per 12. So we will half it, and until we reach 6 x per 11. So let me show you. So at the start, you have 2.4 x per 12 atoms. So when one half-life would have passed, the remaining atoms will be 2.4 x per 12 divided by 2. So you will have 1.2 x per 12, and then you will divide with again with the 2, you get 0.6 x per 12. So point will move to the right side. So you will have 6 x per 11. So that is the thing which they were asking. So count how many half-lives have passed. There are 2 half-lives passed by. So the total time elapsed will be 2 multiply the half-life and 2 multiply 5,700. When you multiply them, you get 11,400 years. 11,400 years old piece is there. So my dear students, today we have attempted this paper, but before going to the finish this paper, the section A of this paper, let me show you the marking scheme of the question number 12. Okay, so sorry, question number 8. Question number 8's marking scheme is showing up on your screen: electrons, protons, neutrons, protons, top box 14, bottom box 7, sensible, having seen. Okay, so the 11,000 years or 11,400 years. So our answers are right. So my dear students, by doing this question, we are done with the 8 questions which were given in the section A. Then we have this from the question number 9, the section B is starting. So this is enough for today. We have done today May, June 2014 2 paper. This theory papers belongs from the zone 2, and this is also available in the red spot. And today in this session, in this video, we have only done the section A of this paper. Section B of this paper I will do in another video, and I will upload that also. So now at the last, I want to thank you everybody who is watching, who are watching these videos and who are preparing the physics and mathematics from my channel. It's a great blessing for me to be able to help so many people, so many people around the world. And so many people write very good comments and send their thanks to me. So I'm also thankful to them because they take out time and they watch the videos. So if you think that this video is helpful to you and this video has helped you to do the past paper of the physics or mathematics, do like the video. Also share the link of this video onto your Facebook account and onto your Twitter accounts and onto your Instagram, because that will help me to promote my channel. And once again, thank you very much, everyone. Have a good day, and God bless, and God bless you all.